Yes. Okay, great. Yes, it's clear. You can see it.
Yes, sir, please. Yes.
Yes. Okay. Thank you very much, Professor Hashan, for the invitation, and Professor Imad and Professor Isham for organizing this particular event. And I am extremely grateful for the Egyptian Society of Soil Science to make this huge program on the occasion of centenary celebration of International Union of Soil Science. While the last two speakers talked more about the two natural resources, whether it is water or whether it is soil, I am going to talk something different. And this particular difference is going to be, based on basically the small landholders who has a land holding around maybe 0.6 hectare, who cannot afford innovation, who cannot afford that sort of technology. So I'm going to concentrate on that particular part. So this is the university from where I belong, Banaras Hindu University. This is a 108 years old, and this is 1 hour journey from our national capital, Delhi. Well, before to initiate this particular proceeding, one thing is pretty clear, that the world faces an interconnected crisis of biodiversity loss, climate change, impairment of soil health. Just we listen, just before my speech, that how soil is getting deteriorated, how soil is getting impaired, and human development inequities under this, huge impact of biodiversity loss, climate change, and impairment of natural resource bases. And if we look at the climate change, and if it is India, and if it is across the different climatic regions of India, it is everywhere this climate change is happening. And it is visible, and we are feeling that heat. Basically, I am working in this part of India. This is the Indo-Gangetic plains of India, where our university is located. So most of our experiments are centered around this particular place. And this is not an exception even with reference to this climate change anomalies, particularly with reference to shorter winterfall mostly, as well as withdrawal of rainfall, which is gaining from the last few years. So there is no doubt, and there is that sort of belief that there is existence of climate change, and climate change is making that sort of impact across India, as I mentioned, as well as, as I mentioned, this part of Indo-Gangetic plains, which is basically the, food bowl of India. But if we look at the footprint of these particular changes, how, whether it is related to agriculture, whether it is related to energy sector or anything else, the other part of transport, right? So although our footprint is less, but if we multiply with this huge population, it becomes something more. And when I'm talking about this particular Indo-Gangetic plains, there are multiple agricultural issues I was mentioning, particularly with reference to climate change or climatic variability. But at the same time, we have issues related to natural resource management, basically with a particular reference to the soil organic matter decline and input use efficiency. And Professor Raghav was mentioning about the genetic narrowing down of genetic basis, which actually make this particular problem much more complicated. And And when I am just concentrating on small landholders, definitely profitability and diversification, the other issues are there. And this part of India is basically, it's a huge, intensive agriculture is over here. But at the same time, we had a long-lasting negative legacies which exist in this part of India, whether it is due to indiscriminate use of agrochemicals or whether it is due to the simplification of our cropping scheme. And once I am talking about this particular natural resource base, with reference to this particular Indo-Gangetic plains, and with reference to different, natural resource-based attributes, with reference to physical parameters, with reference to chemical parameters, with reference to biological parameters, there are huge deterioration that's happening in the last 2 decades. If I talk about very specifically about those physical deterioration, particularly with reference to water transmission, with reference to soil conductivity, with reference to percolation, with reference to exploration of your rhizosphere to a greater volume, things are getting worse and worse, in the last 2 decades. And that has generated and that has given rise this sort of threats. And these threats, basically, if it is 2 decades back, it was more of chemically deterioration dominated. But if we look at presently, it's mostly dominated by physical deterioration. And at the same time, we have issues related to multi-nutrient deficiencies in this part of India, and particularly with the spatial reference to zinc and boron. Because if you look at the zinc deficiencies and boron deficiencies in this part of India, it's almost 60 to 65% soils are deficient in boron. We started working on this particular part of agroecology from 2006, and the present perspective to this particular natural resource-based database is that we are facing a huge crisis with reference to these particular multi-nutrient deficiencies. So as a matter of fact, this particular ecosystem is overburdened, is overloaded. And once it is overloaded, definitely it can be a surface to air missile at any point of time. And if we wanted to make that sort of enhancement in agricultural productivity, which is crucial for ensuring food and nutritional security for all, particularly for the resource-poor farmer, because I was stressing on this particular segment of community. And this constitutes almost 1.5 billion in the whole country. And if we look at this particular Indo-Gangetic plain, where actually our institute and this particularly our institute is located, it's almost 0.5 billion small landholders. So if we don't have some sort of planned adaptation, so in absence of that, and if we have continuously this sort of climate changes or climate anomalies are going to take place, and which is happening in the last 2 decades, could be severe on the livelihood security of this particular group. But at the same time, we have 2 crises, because once we wanted to address those sustainable development goals, SDG 2 and SDG 13, once we wanted to address the issues of food shortage, definitely you wanted to put more of fertilizer, more of inputs. And if you are going to put more of fertilizer and more of inputs, definitely you are inviting the issues of climate change or global warming. So definitely that climate action, you cannot make that sort of rational decision, you cannot take. But even if you are taking an action related to these climate related issues, definitely you will be having an issues of food shortage. So this is a part of one coin of 2 sides. So we need to take that sort of rational decision. And once we go ahead for that sort of rationalization, in most of the cases, we look more emphasis and we give more emphasis on the above ground biodiversity. We underestimate the below ground biodiversity, and that becomes the missing link, and that becomes the weaker point, and there we need to look on and we need to work consistently to get more crop productivity, to get more nutrient use efficiency. Because if we wanted to see that our roots need to explore more amount of soil and more amount of that sort of soil volume with reference to that particular soil solution, which is abundant of those particular available nutrients, definitely we need to go ahead with this sort of optimal strategy. And if we can go with this optimal strategy, definitely we'll be able to reach this sort of peak. Otherwise, we'll have degenerative issues. So what is the intervention we did? This was the intervention we started working in our university initially. We started priming our seeds. And these primers, they are bioinoculants, bioprimers. And those priming actually have those particular seeds to give them some sort of immunization. Whether to address the issues of the biotic stresses as well as abiotic stresses. And once you do that, you can see the change. The seed change is happening. If you are priming it, you can see the below ground biomass as well as the above ground biomass. And that's what really biopriming is. This is going to be a tailored approach towards improved crop performance, nutritional security, and agricultural sustainability for smallholders. And once you talk about this particular biopriming, definitely you wanted to reinstigate adaptive soil management, and which has a broader benefits when interlinked with other natural resources, combating regional challenges of sustainable agriculture. When we started initially working in this particular seed biopriming project in 2008 and 9, we started initially with a single culture. But now we started working with multiple species in a consortium, so that it gets a holistic microbiome approach. And achieving this particular consortia or coming out of that particular association, it needs time. Because starting from isolation and then high throughout your sequencing, network analysis, you go ahead with those sort of the compatibility between those particular species, whether that exists, or whether those particular consortia could able to give more pronounced effects with reference to multiple attributes. So we started working in our university. Then we started the adjoining villages which our university adopted. So we started giving this sort of culture to those particular small landholders who are adjoining to our university. So what is evident? That this biopriming or on-farm biopriming, it is becoming a robust and widely applicable technology which can address multiple issues. So as a matter of fact, once we get that sort of success, we started working with multiple crop enterprise, whether it is floriculture, whether it is high value crops. And the observation was very simple, that we could substitute considerable amount of inorganic inputs. Almost 20 to 25% substitution is possible with this sort of priming intervention. And as a matter of fact, once we advocated this under the different segments of this particular states as well as other states, we published those results. So as a matter of fact, we then become convinced that yes, whatever we are preaching, that actually works in the ground truth or the ground reality. So then we started, and from this particular observation, we have three things which came to our mind. That, as I was mentioning, this fragile system of this Indo-Gangetic plate, and which is, as I was mentioning, this particular, most of them are conventional agricultural techniques they used to have. And once they are doing it for a continuous period of time, they are degrading the soil quality. And these beneficial agriculturally important microorganisms, they can partly substitute the high quantity as well as these costly chemicals required to achieve your global food security. Because these chemicals are very, very energy intensive. And there is a huge amount of subsidy burden from the government side as well. If you look at India, it's almost 1,25,000 crore Indian rupees is being bestowed on these particular inorganic chemicals. So if this beneficial microorganism can substitute 20 to 25% of the requirement, then definitely it is going to give or serve the purpose. And once we look into the performance of this biocomplex, we started working on the mechanism part as well. We started looking into those bioactive compounds, which is helpful for plant growth promotion and stress mitigation, as well as we looked into the molecular part as well, so that which is giving that particular promotional activity, as well as the enzymology we studied in detail. And then we started, converting or bringing this particular seed inoculations to, basically that was the theoretical part I was discussing, and we wanted to bring them or that theory to action on the ground. We wanted to see that whether it works with the small plant holders. And we started this initiative during Corona period, and we know that during Corona period, the entire humanity was challenged. We were not able to, move further. So most of those meetings were, we started working with not, in a remote mode, and we sent those inoculants to those particular self-help group, those farmer producer organizations, and we just, try to make them sensitize about this particular small. We take some sort of, land of smallholders from the eastern part of India, and then we send those particular, bio-inoculants in consortium mode. As a matter of fact, whenever you work with small landholders, basically they don't want any sort of interference with the existing technology. And believe me, we didn't also interfere with them. The only point where we interfere in the whole process is here, when we just ask them to mix those particular seed with those inoculant, and we ask them to put that particular seed with that particular inoculant for a particular period of time, maybe 6 to 8 hours. We also mention the dose, and then they did it and whatever they were doing it earlier. And with this particular innovation, we also started working with another innovation, because I was mentioning that this part of India is very vulnerable to floods, very vulnerable to drought-like situation. And whenever it is a, because this is basically a rice-wheat cropping system, domination of rice-wheat cropping system. So many times it happens that before your rice season, most of your soil or most of your land is flooded or inundated. You don't get time to produce those particular seedlings. So we started working on this seedling factory in trays. Even if you have flooding, even if you have flood, it doesn't make sense. This particularly, stream, that seed is being treated with that particular inoculant and is put into this particular trays. And by the time when that particular huge amount of downpour is there, and when the water gets receded, then this particular seedling is ready for that sort of transplanting work. And this has been a unique word, which was, appreciated by FAO and the World Food Program as well, because we sensitize this farmer self-help group. And you can see the difference. And the difference is crystal clear. Whether it is the above ground biomass and the below ground biomass. With that sort of simple intervention, we could able to make that sort of change. And once we are doing this sort of experimentation, because I say, this experiment we started from 2018, and this is the 5th year of experimentation. We started looking on those particular, environment data, because we wanted to correlate with those sort of climate change variabilities. And we can see that in 2019, there was an early withdrawal of rainfall, and in 2020, there is an early cessation of winter. As I am mentioning that this area is basically dominated by rice-wheat cropping system, and rice is a heavy feeder of water, as well as if you look at wheat, the next crop, it needs, a lengthy winter period. That means you need a long duration of winter for a successful harvest. So once we started, collecting those data, I have 3 years data right now. You can see that those priming intervention has made your microbial vibrancy at a greater height, whether it is related to your bacteria, whether it is fungi. In many cases, you may not be finding that significant difference, but there is always a positive change. And there is also, changes with reference to physical properties of that particular crop, particularly wheat I am mentioning, because once you are growing rice, you are severely deteriorating the physical structure of the soil. So there the resistance to penetration, because if your root is not capable to move further down the profile and can explore a greater volume, then definitely all of your effort is going to be vain. So our priming intervention has improved that particular factor to resistance to penetration, as well as mean diameter, which is a very, very important component, particularly with reference to your soil texture. We also started working with those particular environment variables, particularly with reference to nitrous oxide emission. We started working on from 2020-21. So after rice, and if you look at that priming intervention, it's those plots which receive this particular priming, intervention, there is a huge decline, and this decline was more prominent in wheat. Look at this, from 7.4 to 1.8 kg per 100 kg nitrogen applied. Because this is an experiment which is being conducted not on a controlled basis. This is being done in a small landholder's farm. And you can see the chemical properties also with reference to available nitrogen, phosphorus, potash. So in every case, there is an increase in the availability, particularly with the special reference to phosphorus and potassium. Although there is no significant change with reference to pH. But if we look finally, because our destination is our gradient. If we look at this, you can see that priming intervention has made impact. But if you look at the data of 2019-20 and 2020-21, because I was mentioning about that particular, water withdrawal that happened in 2019-20. You can see there is a decline in yield from the previous year. But the plot which received priming intervention see that the yield was not being, compromised. It's almost equal. And if you look at 2021 data, which I was mentioning about the shorter winter fall, where you can see that in the wheat crop, the yield is not being affected. But here the yield, particularly where you don't have that sort of priming intervention, your yield gets affected. We also looked into the nutritional quality, and you can see the luster, the physical, physical nature of this particular seed. Because this is also going to be impacted on the marketability of those smallholders. If you look at the last chart, if you look at the physical appearance, you can see the minus. Minus means you didn't prime it, and this is your prime filter pension. And with reference to gene NPK enrichment in your wheat and rice grain, although these interventions didn't show significant impact, but if you just multiply this impact, whenever you are going to work out the uptake, taking into consideration their yield, definitely you are going to make a severe impact. So what is evident out of this small exercise, which is we are trying to establish from the last 6 years, that this microbiome science is crucial, and particularly for the present context. We need to embrace these particular agricultural practices. This is simpler agricultural practices that doesn't warrant any sort of rocket science, that depend on greater use of fertilizer and water to meet the growing demand of global food requirements. An effective microbiome, which I was mentioning of microbiome science, can offer benefits to its host, including plant growth promotion and nutrient use efficiency. And once we comprehend this particular science of biopriming, definitely we will be able to address the issues of UN sustainable goal with reference to 2, 1 and 13, many others. Our efforts to minimize the renewable energy resources, non-renewable energy resources, and promote the use of microbial resources at the community level need to be emphasized, because I can tell you, at our national level and the government level, we are also advocating the regenerative agriculture which is very close to nature, nature-based agriculture, right? So biopriming is becoming or is emerged as a pragmatic technological action in achieving this tripartite goal of food nutritional security, which is very, very important, particularly for the small landholders. Environmental stewardship, because if we cannot run the business without looking at or without ignoring your environment and agricultural profitability, which is the utmost importance for these smallholders under this different agro-ecosystem. Although this is a small intervention, but small is always beautiful. I must acknowledge my university, who actually provide me that funds for working out this particular research, and I'm also thankful to all the collaborators who actually helped me to carry out this particular piece of research. And this is this I couldn't achieve without the help of my extended team, which are very important for me, who actually, through their multiple dissertation, they undertake this sort of research, and which are very important, observation, particularly for these small landholders. So thank you very much for your attention. I am extremely grateful to Professor Hashan for this unique opportunity, but I would love to visit the third time, because I already visited Cairo and Alexandria twice. So definitely my next intention will be to visit Professor Hashan, and by that time I will be able to exhibit the whole report, because by that time the whole exercise will be all over. So thank you very much, Professor Hashan, for this wonderful opportunity. I'm extremely grateful. Thank you very much.
Thank you, Dr. Amitava. It was a really interesting presentation, and hopefully you always be with us in our upcoming